Welcome back to our Math A&A Friday. Today we go to SL 1.2. Unfortunately, 1.2 is called logarithm. It's a very make you a panic, phobic. You don't know what is it about. Okay, now talk about logarithm. Okay, I hope after this sharing you know it more, get used to it. Just remember, logarithm is a game to find the exponent. The result is an exponent. Just tell yourself 1,000 times. The result of a log is an exponent, and then you can use the exponent law you learned before to tackle it. So let's go. Okay, remember, bring some paper. We have example to work on. Okay, first definition. Okay, we are still on the topic 1, the number in algebra, SL 1.2 logarithm. The whole thing is a SL, but very complicated, but very fundamental to us. Okay, introduction to logarithm. Logarithm is the exponent of the base to produce a given number. How to get this number? By making the base exponent, and log is to find out that exponent. Logarithm is the reverse function of exponent. Okay, you can say logarithm is the inverse function of exponent. Okay, for example, if you can express y equals ax, we want to express it this way, and what's the number x? Easy. Ask calculator to calculate log y to the base a, and then equal x. First of all, you need to learn how to say it. Log ay. Okay, log y to the base a. Log y to the base a. Okay. A is the base, x is the exponent, and log function is to find out the exponent with the specific base. Okay, so we call it log y to the base a. A typical value helps us to understand a lot more. Okay, a to the power 0 is 1. Okay, so how about log 1? Log 1 becomes 0. A to the power 1 is a. Right? How about log a? Log a becomes finding out the exponent becomes 1. Right? So if finally log anything with the base of itself is 1. Log 1 with any base is 0. Funny. So when the base increases, you remember then the base increases, okay, and then the exponent will decrease, right, for the same number. So the logarithm will decrease, so inversely moving, okay. And then the domain of a log function is a 0 to infinite. So if it is a negative number, it's impossible to find a positive number's exponent become it, right? So we have to constrain ourselves, okay. The original number has to be positive, okay. But the range of log can be negative infinite to infinite. Remember, negative exponent means 1 over, right? It means for small number. So remember, the domain is 0 upon infinite. The original number has to be positive, okay? But the exponent, the log function, the range can be a negative infinite to infinite, okay? And range of the base a, okay? We want a to be positive also, okay? And not equals to 1, because 1 no meaning, right? Base 1, okay? 1 to the power anything is 1, okay? So we can't have to find another number. So there is a larger than 0 and a not equal to 1, okay. And if we use the base a equal 10, it's a normal one, okay. We can omit the 10 in the base, okay. So log y to the base 10, you can say just say log y, okay. We understand. We say nothing is the daily lives one, okay. Base 10. And okay, try to do it, okay. Given b equals 9 to the power a, express log b to the base v in terms of a. When you name it, you know it, okay. Work it out. Welcome back. Okay, so change it first. Okay, I want base v, so v to the power 2. Right? So v to the power 2a. Okay, just not it is 2a. Sorry, too quick. Yes, got it. Next one. Okay, introduction to a base. You get a special base. You call it Euler number. In a long time ago, learn how Euler, famous mathematician in Swiss, okay, they introduced E. Okay, it is named after him, Euler number. And E is a special number, 2.718, blah, 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 blah. It is an irrational number. Let us stop. Okay. For a base E, okay, EX we call an exponential function. Okay. If we, on the contrary, want to find the exponent x to the base E, we call it log E. And log E, we call it a natural logarithm. And natural logarithm has a symbol Ln. Okay. And Ln, sometimes we can pronounce this as nan. Okay. So log y to the base E is nan y. Okay. And natural logarithm is a special logarithm. It's still a logarithm. Okay? It's the same domain. Remember, 0 to infinite, same range. You get negative infinite to positive infinite. And by the E, okay, you find out in the past paper they introduce different function in terms of E. Okay, EX plus E minus X over 2. Very funny. Yeah? And then EX minus E minus X over 2. Okay, very funny function. Again, you find out multiply them, square. And then you saw that their square has some common terms, okay? If you subtract them, it becomes number 1. So f and g is just like sine and cosine function. Remember sine square plus cosine square equal 1, right? Pi brackets. Now f square minus g square equal 1, so it's minus. Similar, so we call it a hyperbolic function. This is not in our curriculum, but sometimes I saw it in the past year, so I introduced to you first. For example, in the past year, you can say that they introduce fx and gx to you, and then ask you to manipulate it. So it's better to understand these two functions first, okay? Sometimes it appears. I don't want to say always. I'll bring up a paper. Start from the complicated side, left hand side, and try to do the right hand side. Pause the video and work on it. Hello, welcome back. Let's check the answer. So take out the 2 to the numerator first, right? So expand it, okay, 3ex minus 5 and then minus 2. 3e minus 6 plus 5, okay, 8, okay. And then e minus 6, I don't like it, so move it up. We have ex and then become e to x, and then the result are the minus sign to move away. That's it. Remember, it's a song question, right? So remember, do it as many steps as possible. Don't jump the step, you lose the mark. Okay? And then sum and difference of logarithm. So low law for products and quotient of logarithm. Remember, logarithm and exponent are the reverse function. In exponent, there's no law for sum and difference of exponent. But now we go back. Okay? Low law for products and quotient of logarithm. Because logarithm is calling the index. For example, log x plus log y. If you add two exponents together, it means that you're finding the exponent of xy. If log x minus log y, okay, subtracting two exponents, you're finding the exponent of x over y. So it's the rules. Okay, so remember it. Okay, so if it is not a x plus or minus y, no rules, no rules. Okay, so you may need to use these rules as several. So to look at it, just remember it. Log is the exponent. Okay, okay, try to solve it. Simplify this one. Welcome back. Separate them first. Okay. Multiply two things log, it means log them and then plus them, right? The first one, log 10, 10, same base and the number, so x. Okay. And then now 10, take it out, 10 to log 8. Log x. Okay. And then arithmetic mean of logarithm. Okay, we talk about arithmetic mean. We encountered it several times. Actually, it's simple average. Okay. Special sum of logarithm. Arithmetic mean of log a and log b. Okay, we can say it's log a plus log b over 2. Definition, right? Add the two numbers together and multiply by 2. Okay. And then these two are log a plus log b is log ab. Over 2 is a square root. And then sometimes they will make it more complicated. Arithmetic mean of log a plus b and log a minus b. Just relax, just do it the same. Multiply together and then a squared minus b squared, and 2 take out square root. And then find the exact value of the arithmetic mean of log 3 and log 7. Okay? Except where the log are possible, so it has to be log something. Okay. Try to work on it. Pause and do it again. You can go back to the previous previous page to look at the logs. Okay. Welcome back. Checking time. So arithmetic mean it like this way: plus over 2, and then they add together. Okay, log 21, and then half is a square root. Okay. Got it? Well done. So linear combination of logarithm. Okay, remember logarithm is an exponent. If you are multiplied by y, multiply the exponent by y, it means the exponent is exponent, right? You're finding x to the power y is an exponent. Okay? So the y can move inside, become an exponent. So remember, for a log, the number outside can move inside, become the exponent. It's the exponent's exponent. For example, 1 over n also move inside, become exponent, but becomes the n foot. Negative 1 also become negative 1 exponent, so 1 over x. So remember, the factor outside can move inside the log and become the exponent because it's the exponent's exponent. Okay, so transform the exponential function to linear equation of logarithm y equal a x m. Okay, if you have this equation, it is x to the power m is not a straight line, but you take the log for both sides. Log y equals log a plus log xm. Take out the m, change it into this. Okay, and you will see beautiful straight line if you plot log y against log x. It's the basic skill in science I, right? You have some strange relationship. Going up or going down is not a straight line. You log it, and then it will become a straight line. And they'll give you the exponent by the gradient. Okay. And then express an unknown logarithm in terms of known or logarithm. Okay. The question is a game. Okay. They give you x equal log a, I know it, and y equal log b, I know it, and then they want to find a log k in terms of this. Okay, so exponent in terms of exponent. So remember, make k is a to the power m and b to the power n. Because when you make it this form, I take a log, and then log k becomes m log a plus n log b. Good. I know log a and I know log b. Mx plus my x. But in some cases, you need a log 10 equal 1, log 100 equals 2. Okay, and then express k in terms of this, and then get the L out. Okay. Example. Sorry, too quick. Okay, look at it. Okay, express a in terms of b. Okay. Welcome back. The problem is 4. So first of all, you have expressed 4 in terms of log. What is 4? Log 10,000. Yeah, change it. And they can add together. And then take out the log together because you have log a equals log b, right? Good form. Okay. So a squared equals this one square root b over 100. And large exponent. For large exponent, don't ask your calculator to calculate this one. 2024 to the power 2024, it will be L. Okay. Remember, if we want to compare big exponent number, remember, take the log. Because they are increased and decreased at the same side. Okay. So we take the log. Okay. If the log is bigger, the original number is bigger. If the log is smaller, the original number is also smaller. So take the log and do the comparison, and the calculator can help you if you take the log. For example, compare these two numbers. Take the log and to see which number's log is bigger, and then the original number will be bigger. Okay. Pause the video and work it. Okay, welcome back. This one is a paper 2. Use calculator. You find out, okay, this one is a 6,600. This one is a 6,500. Oh, a little bit bigger. So the original one is a little bit bigger than the previous one. Got it? Well done. Next one, the base of logarithm. Okay, you can change the base of a logarithm. If you change it to a larger base, and then the exponent and the log will drop. Okay, it will become smaller. How to change the base of a logarithm is very complicated procedure. You don't need to prove it, you just need to use it. Okay, for example, log x to the base a. I want to change it to a base b. Remember to use. Okay, remember to use. Make it a fraction of 2 log. Okay, and then the original x become the numerator, the a become denominator, right? And then you can change to any base. Any base. So remember again, okay, log x to the power a, x become numerator, the original base become the denominator, right? And the base can be n. So it means that effectively you change the base from a to b by dividing it by log a to the base b. Okay, if you take a b as 10, okay, so log x to the base y is log x over log y. And then if you change the base from y n to y, okay, it means the same thing, to the base y, and then the new denominator can be simplified to n. Okay. So remember, log x to the base a become log x over log a, any base. And the base. So try to remember it. And then now is a working time. Okay. Change the base of this thing to a 25. So log 25 something. How to do it? Pause and do it. Welcome back. Remember, x is the numerator, 5 is the denominator. So x is the numerator, 5 is the denominator, and this one, okay, square root 5 is 25, right? So 1/2. Move it up 2. Maybe we can move the 2 inside 2. We can say log 25x squared. No problem. Okay. Next one, conversion between a logarithm. Okay. Quotient of 2 logarithms of the same base is a new logarithm. Yeah, just reverse what we learned, right? Change the base. Okay. So if you have z equals log x to the power y, okay, 1 over z. What is 1 over z? Very funny after this calculation. There is log x to the base y. Oh, if you swap the number and the base, and it become 1 over. Crazy. How about add a negative? Add a negative means a 1 over the original number. How about z equals log xy definition? You can move the z to the other side, becomes a z root. Okay. That's it. Application time. Log b to the base a equals log a to the base b. What? Find the relationship between a and b. What? So crazy equation. How to solve it? Okay. How to show people the relationship between a and b? You might think, you may have a feeling on a and b very strange, right? Pause and work on it. Welcome back. So change 1 becomes a 1 over log a to the base b. The same. Move it up. And then log b to the base a, 1 log, negative 1 log. Log must be a positive number. So we get this one again. And then log b to the base a is 1, so a equals b. Ooh, funny. They're the same actually. But you have to show people they're the same because I can feel it, they're the same, right? And so that's when you solve exponential equation. Okay, if you change it into this good looking ax to the equal ay, then x equal y. We have talked about it before. Okay? Because when you change it so good looking, you can take the log and then x equal y. And then when you're doing the thing, I just give you some hints. Okay, log kx minus log x is log k plus log x minus log a. Wow, log x disappear, become log k, become a constant. So bear in mind this trick. Okay, log 3x minus log x is log 3. Okay, we have this equation that express y in terms of x and z. Very complicated at first sight, but you know how to do it. Okay, take the log. Yes, I'm gonna take the log. Okay, welcome back. Yeah, take the log, then it become x minus y equal log z, right? Base 10, okay? And then so I'll express y, okay, y move to the right hand side, log z to the left hand side minus, so y equals x minus log z. You got it? Well done. And next one, remember the ratio logarithm is another logarithm, okay? Just numerator is the number, denominator is the base, okay? Base. So if you have three relationship, okay, and then they ask you to find the ratio of the exponent, just remember it's the ratio of the log, okay? Sometimes you can plus or minus them, okay? Add them together. Just look at the logs, okay? And then exercise time, okay? Work on it. Of course, the first A is C, right? A and C relationship, and then the C and B relationship. Find out the two number, really a number, and then add them together. Check it out. So A squared equals a C to the power C fifth, okay? And then log them, and then 2. So log A over log C is 5 over 2. 2.5 is a number. B3 and then C5, okay, and V5 and V over 5, C over 3. Remember which over which, okay, don't mess about. So 2.15 plus C16 is 3.1. Exact value. Excellent. So I'll solve a logarithmic equation, okay? If we have log function, same base, excellent, then x equal 1. So we need to change the whole logarithm, okay? Make the two sides a whole logarithm, and then they can cancel each other. Be careful, whole logarithm, not plus or minus. You need to simplify them first, okay? Very complicated equation with logarithm, change it to log x equal log y. Work with it, and then this is rewarding because x equal y, and you can solve the problem. Okay, how to solve this one? Pause and work on it. Welcome back. Now it's a tracking time, okay? So take the log. How to make 2 a log? Log 100, remember, base 10. Right? Or 10 to the power 2 again, then 100 plus 5, 105. Oh, so easy. Yeah, so easy, okay? So don't think log is crazy, just remember the definition, okay? And how to operate a logarithm? Remember one thing, golden rule: 1 equals log 10, 2 equals log 100, 3 equals log 1000, okay? Group both sizes as logarithm. And then you log fx equal log f gx, then fx equal gx. And then you can got the result. But remember, really remember, substitute back to the equation. Right? If a logarithm of a negative number appears, then you have to reject the solution. Be careful. Some solution may be not allowed because it's a log negative 3, log negative 7, okay? Okay, for this one, okay, fine, express y in terms of x, okay? Try to work on it. Yes, make them log a equals log b, okay? Move the 5 inside, and then 5x is equal y to the power 5, so 3/4 of 5x. Thank you, okay, we go through it, okay? It's a very complicated question of a logarithm, okay? Complicated concept, so I recommend you to do past paper or do the exercise from the textbook, okay? I hope today when I'm sharing you help you to understand more. If you like sharing, remember like, subscribe, and share it with your friends. Okay, remember logarithm is an exponent. See you next FNA Friday. Bye.